Hi guys, this is homework 10 preview for Discrete math class. Alright, so let's begin. I think the first two problems are problems that asked you guys to prove the second and third part of Theorem 1. Okay, so I'm going to show you guys how to prove part 1. Let's go over that together. Alright, so part 1 says, given that A, B, C are integers, then A divides B and A divides C, then A would divide B plus C. Alright, so from the first given A divides B, we can rewrite this as an equation. This would be equivalent to B equals to A times K1, where K1 is some kind of integer or constant. Okay, and we can also have A divides C, so this is equivalent to C equals to A times K sub 2. Okay, and here, where K1 and K2, these are some kind of integers. Alright, so from these two equations, let me go ahead and add. So we have B plus C equals to A K1 plus A K2. This, you can group it, and that becomes K1 plus K2. So eventually, we have those two parts, which gives us to the conclusion, so therefore, A divides B plus C. Okay. And that's done. Alright, so please try to prove the second and third cases. It's very similar, as long as you have these equations set up using the definitions. I think you guys can easily prove the remaining part of Theorem 1. Alright, so next problem is problem 5. Show that A divides B and B divides A. So this is equivalent. This problem is pretty similar to problems 3 and 4. Okay. Alright, so very similar to what we just did. Let's go ahead. And from this, we can get to B equals to A times K1. Okay. And from the second given, we can get to A equals to B times K2. Okay, where K1 and K2 are integers. Alright, then we have to prove this part. There are two ways about going this. We can either, let's try to add these two equations. That's what we did. Improving the part 1 of Theorem 1. So if we add these two equations, then we get A plus B equals to A K1 plus B K2. Then I don't think we can get anywhere further. So unfortunately, I don't think this is what we can do. Well, let's try substitution then. If not, we can also try multiplying these two numbers. Alright, but I'm going to substitute since A is K1. A is B times K2. I'm going to bring that and substitute here. Okay, so this method didn't work. So we're going to have B equals to B K2 times K1. And we can divide both sides by B, so that's going to give us 1 equals 2, K2 times K1. So here we have two cases. K2 is going to be 1 over K1, so either K1 and K2 be 1, or both of those numbers has to be -1. Alright? So there we go. This works, and we have proved that A equals to B, or A equals to minus B. So this is one proof. What if we tried multiplying these two? Okay, so let's multiply the equation 1 and equation 2. Then we have AB equals to B K2 times A K1. Let me divide both sides by A, so that gets divided out. And also divide both sides by B. So that also gets divided out. So we get to the same solution where we have 1 equals to k2 times k1. Okay. So 1 equals to k2 times k1. So this again gets us to a solution where k1 and k2, either they have to be 1 or they have to be negative 1. So in our case, if k is negative 1, then let's say if k1 and k2 are negative 1, then b is going to be, or I guess we would use, let's use this case, if k2 is positive 1, then we have a equals to b, or if they're both negative 1, then by plugging in negative 1 to k2, we have a equals to negative b. And our proof is done. Okay, so for the next problem, problem 6 and 7, they're very similar to problem 8. So I'm going to go ahead and do problem 8 for you guys. Okay, so prove or disprove that A divides BC, where A, B, C are positive integers and A is not greater to 0, then A divides B or A divides C. So this is a special case. I think the 6 and 7 were just proving, so we know that these statements are true, but this is a special case, prove or disprove. So you guys can try to prove this, which is going to be similar to the previous problems, but you'll realize that something it's just hard to prove or some other information is missing. So now I get a sense, maybe I have to disprove this. There are many ways of disproving it, and I think the easiest way is if you can just find one counterexample, and that is a legitimate proof that this statement is not true. Okay, so let me give a counterexample, and I can do, let's say, let A equals to 6, and let me also define B equals to 2, and C equals to 3. I got to these numbers because B divides A, so this also works for all of these cases. Okay. All right, so if this is the case, then A divides BC because 6 divides 6, but we also get to the case where A will not divide B, and also A will not divide C. 6 is not going to divide 2, and likewise 6 can't divide 3. And that's it. So this, showing one quick counterexample that you guys can find, this is a sufficient proof, or this is a disproving that the statement is true. Alright, so I assigned 14 A through C, and very similarly, 13 A through C. I will go over this one. Alright, so we have our A's and B's defined, and we have to find the C in this interval, and 0 and 12 is included. Alright, so for A, alright, so C is congruent to B times A. So A is 4 mod 13, and I'm going to plug that into this A, and we know by one of the corollaries in the book, this is going to be 9 times 4, and mod 13, it's just going to be repeated, or it's just going to be just 1 of mod 13. Okay, so this is 9 times 4 mod 13, and this is same as 36 mod 13. Okay, so let's try what this number is. So I'm going to divide 36 by 13. It goes into twice, and this is 26, and there is a remainder of 10. So this is just 10. Okay, and 10 is in the interval, so there we go. This is our answer. So C is going to be equal to 10. Alright, let me do B. Similarly, I'm going to substitute B in here. So I have C being congruent to 11 times 9. And they're both mod 13. So by corollary, we can just write that. So this is 99 mod 13. And I can go ahead and calculate this. So this is going to be 99 divided by 13. It'll go in 7 times, and that would be 191, and has a remainder of 8. So we know that this 99 mod 13 is going to be 8. Alright, so 8 is in between that given interval, so we can say C equals to 8. Okay, so let me just erase this. Let me do part C. Okay, so we have A plus B mod 13. So C is congruent to A is 4 plus 9 mod 13. Also refer back to the theorems and the proofs in the book. So this is going to be 13 mod 13. And as we know, 13 divided by 13, it's going to have a 0 as a remainder. And since 0 is included, that is our value, so C is going to be equal to 0.